quadratic inequalities in one variable. So these are quadratics, but they don't have the y in them. So what you see here on the left-hand side is a quadratic, and what we want are all of the x values that when you plug them in will give you an answer that's greater than 0. Now, this, if we graph that as a parabola, this is one that would open down, and we know that because the negative sign in front of the x squared will make that parabola open down. Now, there's going to be a region of that parabola that is above the x-axis, and then the rest of the parabola is going to go down below the x-axis. So what we want to know is, where is that parabola going to give us values that will be above the x-axis? What values that we can plug in for x are going to give us answers that will be positive? So the first thing we're going to have to do is find out where the x-intercepts are. Where are the zeros of that quadratic? And luckily this is one that can be factored. So we'll factor that, and we find out that -3 and 6 are the two zeros, the two x-intercepts. Those are the two numbers that if we plug them back in to minus x squared plus 3x plus 18 will give us 0. So the next step is to construct a number line, and you can see here that we don't bother to put in the y-axis because we're only dealing with what happens when we plug in different values for x. The -3 and the 6 would be where the x-intercepts are, so I've got those labeled. Now that parabola, I've put a little sketch in there just to remind myself that this is a parabola that would open downwards. And you can see that the little U shape there that's above the x-axis would be between -3 and 6. So those are the x values that are going to give us results that will be greater than 0. You notice that the inequality here doesn't have the equal sign underneath the arrow, so that's why I've labeled the -3 and the 6 with open circles rather than closed. And I've made a heavy line between the -3 and the 6 to indicate that's where a solution is. So the only thing we need to do now is write down the domain in function notation. So you can see down at the bottom here in step 9, I've got x such that -3 is less than x, less than 6. So all of the x values that are sandwiched between -3 and 6, but not including -3 and 6, those are the solutions. And then you just have to stipulate that the x's are all real numbers, and you're done.